let's take a look at problem 2. I've written up formula for 4, and obviously this is the same as operating with minus gamma, because minus the identity does not change sign, but then all of these will change, all of the A, B, C, and D will change sign. So basically, we have to show that these two are identical. Now, what can we do here? Well, let's work on the left part of it first, and then multiply on both sides by I to C halves, and cancel I to 1/2. So we get to be compared with I to C minus D minus C. This, of course, is defined by minus D over... Oh, that depends upon the sign of C, of course. So it's not so simple as I thought. A minus does not mean that the number is negative. So let's take a look at the symbol, what actually happens. So in case C and D both are positive, and minus 1 over C it's minus to, what is it, C minus 1/2. So we may actually write it as I raised to C minus 1 Let's hold that thought for a minute. Now if it's plus minus, then this is positive, so I think it's the same as minus D over C. And since D is positive, we can write it like minus 1 over C D over C. And this is again I to C minus first D over C minus plus now this is negative and this is negative, so it's minus D over C. Oops, That was wrong. Oh yes, when C is negative, then this is negative and D is negative, so it does change sign. So when we are here, we have the negative C and the negative D, so it's a change of sign. So we get the same. And when they are both negative, there's something I don't understand here. It's right. Well, minus D over minus C, they are both positive, but over here they are both negative. So there is a change of sign. These are both negative, so there's a change of sign. Here they are both positive, so there's no change of sign. Here, minus D over C, both are negative, so there is a change of sign. And here both are negative, so there is a change of sign. That's very strange that in all these cases we get the same, except when they are both negative. That means I have two cases, which we must take separately. So first, plus plus, plus minus, minus plus. It gets I to C minus 1. D over C square root I of CZ plus D at I to C2 This is minus 1 to C, and I minus first, that's minus I. And the second case, so I'd like to show first that the squares agree. If we take case 1, these give unity when squared, so it's minus 1. And this squared I to 1 minus c. This is silly, really. Well, let's do it. No, we do it down here. I to 1 minus c times minus I cz plus d equals, so I, imaginary unit times this gives unity, so it's I to minus c cz plus d. That's not particularly the same, because c can be any odd number. Oh, no. So it's minus I to c. So I've got something wrong, but that was the first try. Well, as soon as I had saved, no, I didn't even have time to save it. As soon as I stopped recording, I realized that I had taken out these two, so we don't need this, or rather we should not have that. So this is basically what we should end up with when squaring, because this is a way, so it's minus I. We took this away, put it over here, and then this squared gives unity, so that's the result. And we have that in case 1. In case 2, not quite. This squared gives minus to cth times I cz plus d. And then even though the squares are the same, then we still need to see that, to check that we get the right branch using the correct branch of the square root. So we have to say set z equal to I, the imaginary unit, and then take the right square root and see that that they agree as is. Well, I have no idea, so I'll just go through it again, maybe on paper, and then we'll see what I find. I've had a little time to look at it, and what I noticed was that C is odd, meaning that this gives a minus. So this is I d over c square root I c z plus d. And in case 2, this is the same. It gives minus I now. I'll just underline what we are working on. So in case 1, this is the guy that must be compared to this. And in case 2, that was squared. This is the one. And here, if C is positive, then this is in H, meaning this has negative real part. So the square root, it goes different ways depending on the cut, on the imaginary part being positive or negative. Oh, right. That's a little... I'll just do that on another sheet of paper. Hello, it's now Friday, February the 9th. And we have developed all the technique necessary to finish the problem. First we start with the left-hand side, so to speak. So it's C minus di. So this is the complex plane, and we have, if C is positive and D positive, then we are down here. So this is plus plus, plus minus, minus minus, plus. No, here C is negative, so it's minus plus. And then when we take the square root, this goes up here. And this up here, and plus plus here, and minus minus plus. Here. And now we have to do this with the other side. So first minus C plus di, this is the square root, minus C plus di, so this is minus plus, plus plus, plus minus, and minus minus. And then we take the square root, now we shall multiply with the factor minus or plus minus I that we have here. In case plus plus, multiply by minus I, that agrees. In case minus plus, we multiply with minus I, that agrees. In case minus plus, we multiply by minus I. Wasn't that the one that agreed? Plus minus, we multiply by minus I. So that's wrong. So we have to redo that. And then minus we multiply by I, which agrees. So there was one error, and I will leave that to you.